Hi, I'm Mitch. I created the core village region generator and the core module loader infrastructure. I would like to talk about the latter first. The main file, village.py, runs our modules sequentially through the main method, ensuring each module successfully executes before the preceding one is also done. The village areas are split into regions, which are represented by an implementation of class called abstract region. The village has 4 region types: the overarching village region, house region, decoration region, and pathfinder region. All of these regions have similarities, being they contain a generate method and have upper and lower bounds. As shown on the screen, in order, the regions generate by village, red, house, green, decoration, orange, and pathfinder, grey. Each region takes into account the location of other regions and ensures they do not overlap. The Pathfinder region also goes to a designated city centre and avoids any other unwanted regions that may overlap. The module system uses an abstraction style of coding, with the previously mentioned abstract region class. The abstract region class is the base of all of our generation and branches off depending on the implementation needed. Now, onto my second contribution, the village generator. Initially, the village generator used a dynamically sized marching cubes algorithm to find suitable land which houses could be placed on. However, this algorithm was extremely slow and could take minutes just to find land to work on. Although the marching cubes algorithm did have a better outcome, it was not worth the computing time for a negligible visual benefit, which were mainly a non-cuboid village and being able to wrap around bodies of water such as rivers. I decided to use just a simple cuboid boundary for the village as it was far easier and faster to compute and the downsides could be worked around. The village generator has different randomly generated variables which determine things such as town size, minimum and maximum house size, house spacing, land height variation, and house density, all of which are taken into account when searching for suitable regions to generate houses. The most important part of which is height variation. The algorithm queries the height of all blocks within a cuboid region, and if the maximum difference does not exceed a set limit, a region is created. Afterwards, those regions are passed to the next modules to generate.
Hi, my name's Eddie. I was responsible for the road and external decorations of the assignment. For the road generation portion of the assignment, I've implemented a version of the A-style algorithm. For the heuristic, h-cost, I used the Euclidean distance formula, and for the movement cost from one block to another, which is the g-cost, I used the Chebyshev distance formula multiplied by the absolute difference in height cubed between the two blocks. By using the Chebyshev formula, it makes it so that I can visualize the land like a 2D chessboard where the cost of each block moved in the xz direction will be equal to 1 multiplied by the cube factor of height difference. This allows us to use getHeight to get all the highest surrounding blocks of a particular block and set them as its neighbors. The highest blocks are usually always on the surface of the land, so we're able to map out the natural terrain and find a path to it. This makes the roads look the most realistic, although it comes with its downsides, where it'll struggle to find a path if there's nothing connecting two pieces of land. However, for the requirements of this project, it should suffice. Also, to make sure the algorithm does not find a path to a house, we set the blocks in the building area of the houses as unpassable blocks, so that the algorithm knows to avoid it. Apart from these two differences, the pathfinding should be pretty similar to other A-style algorithms. For the external decoration part of the assignment, I've made 3 hard-coded sets of decorations. 2 of them have some randomization except for the lamppost. Every time the flower bed generates, it'll be a different set of flowers, and for the tree, the lamp on the barrels will change position every time it is generated. The lamppost though will be exactly the same. These decorations will then be placed randomly around the village by Mitch with his village generator.
Hi, I'm Chris. I created the code for the house generation part of this project. I split it up into different parts where I would take on each room generation of a single story, and then I would generate different story levels and the roof and then the floor. Firstly, the number of stories a house has and the building materials for the houses are randomly chosen from set values. After choosing these values and deciding what to build with it, I used a recursive subdivision algorithm to split up the area within the house parameter into smaller rooms. I did this by setting a minimum area a room can take over and comparing it with the remaining area recursively until all the spaces are filled up. Before this method, I tried to split up the house into grids after generating the north, south, east, and west walls of the house, so like a whole perimeter. But I found it much easier to generate each room and then in turn creating the north, south, west, east walls by combining all these rooms together. One thing I made sure to put a detail into is the connection of all these rooms, where I made use of a depth first search method to compare all room adjacency and create a doorway into each room. So no matter which way the room is generated, it will always be connected one way or another. This is done through a recursive algorithm as well, by always comparing the parent and child node and pointing it to the next one as when they have any intersections between the coordinates of the blocks. Thank you.